Let's say we draw a single card. A single card is drawn. From a standard deck of cards. What is the probability that we draw a spade or a face card? What is the probability we draw a spade or a face card? Okay. Well, all right, so here, just another example. Spade or face card. So we do the probability of spade plus the probability face card, then minus the probability that it's spade and a face card at the same time. All right, so yeah, we're back to our cards here. Spade, what's the probability of it? 13 out of 52. There's 13 spades in the deck, right? Ace through king. 13. Out of 52 cards, yeah, in a deck there are 52 cards altogether. With me on that. Face cards, well, that's they count face cards as Jack, Queen, King. So how many of those are there? Jack, King, and Queen in all suits. So it'll be 3 of them in each suit. There's 4 suits. Be 12 of them. But I have to subtract off how many? How many are spade and face card at the same time? Jack of spades, queen of spades, king of spades, right? 3 of them. 3 out of 52. What do we got? 22 out of 52. 22 out of 52, which is 11 out of 26. Okay. All right, well, let me do another drawing card problem. You got that one? That one sound all right? Okay. Let's say we draw a single card again. Standard deck. What is the probability of drawing a club or a red card? Club or red card? Well, same thing. Probability that it's a club or a red. I would do the probability of club plus the probability of red minus the probability that it's club and red at the same time. Well, clubs, like spades, there's 13 of them, right? 13 out of 52. But how many red are there? Which ones are red? Hearts and diamonds are reds. So there's 13 hearts, 13 diamonds, so it's 26. 26 out of 52. Red ones. Now what about clubs? How many clubs are there that are red at the same time? Well, the clubs being black, how many of them do we have that are club and red at the same time? We don't. That's 0. Okay. All right, yeah. In this case, this last part is 0. 0 divided by 52 is 0. So really, that part is not going to amount to anything in this case. It's just going to be 13 out of 52 plus 26 out of 52. That's 39 out of 52, which is reducible by 3. Both of those divide by 3. That'd be 13 over... Oh, no, it's not reduced by... Oh, it's reduced by 13. That's what I meant. 13 goes into that one, and that 13 goes into that one. That's what I meant. Okay. All right. I was thinking ahead of what I was going to say next. All right. So, in this case, what we have is a special case of this OR probability. What we have here is, in this case, unlike all the previous examples we went through so far, club and red couldn't happen at the same time in our little events here. That's different than all the other ones we've encountered. These two events are what are known as mutually exclusive events. Mutually exclusive events is what we have here. Are events events that cannot occur at the same time. Isn't that what we have here? We cannot draw a club and a red at the same time. So those are called mutually exclusive. Now, one thing that we might note too is that when you have mutually exclusive events, this last part's always going to be 0 in your formula. So the formula shortens up if you have mutually exclusive events to this. If A and B are mutually exclusive, then the probability A or B is just the probability of A plus the probability of B. What's missing in that formula? The minus P, A, and B is missing, right? I don't have the minus P, A, and B here. I can leave that off because, I could put it in there, but might as well leave it off because the probability of A and B is 0. So, in other words, the formula, if A and B are mutually exclusive, the formula just shortens down all the way to this. Okay? Another example, flip 2 coins. What is the probability of getting 2 tails or 2 heads? What is the probability of getting 2 tails or 2 heads? These events are mutually exclusive, aren't they? Because can I get 2 tails at the same time I get 2 heads? No, obviously not, okay? I can't get 2 tails at the same time I get 2 heads. So the probability that it's 2 tails or 2 heads would just be the probability that it's 2 tails plus the probability that it's 2 heads. I just have to add those 2 probabilities up because they're mutually exclusive. All right, what is the probability that it's 2 tails? Well, you've got, again, heads, 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 tails, tails, heads, Tails, tails. So the probability that it's 2 tails, you got 1 out of 4. Probability that it's 2 heads, you got 1 of those out of 4. So it's 2/4, which is 1/2. Okay. All right.